The range we said is all the x's, any inputs you can get. The domain is any input. So 3, -1, 2, -2, and 0. Those are the only possible x's we can get in. Only possible inputs. What are all the possible outputs? 2. 0. Un. And in French, trois. Identify the domain and the range. Sometimes we'll see some functions where the domain, we'll see some functions that the x's we're allowed to plug in is any real number. We'll see some functions where the range that we can get out might be, say, only y's that are greater than 3. If I'm giving you a relation that's just a bunch of points, and the only points that we can plug in, the only inputs we get are the x's of the inputs, and the only y's we'll get out, the only outputs are the y's that we see. Representing this relation using a graph, that's graph the points. So you can get, say, 3, 2. You can say -1, 0. Say 2, -1. -2, +1. And 0, 3. Could be using a graph. Representing using a mapping diagram is what looks below. To use a mapping diagram, I'd have an input and an output, a domain and a range, or an x and a y. I'm going to list every unique domain entry, and ideally we'll put them. We put them in order. I mean, you can put them in whatever particular order you want, but you want to list them as the unique entries. So we don't want to put any repeats. In this case, none of them are repeated, so our mapping diagram will look something like 3, -1, 2, -2, and 0. We'll list all the unique range outputs. In this case, they're all unique as well. So we'll have 2, 0, -1, 1, and 3. And we'll literally map the input that goes to its output. So in this particular arrangement, 3 goes to 2, -1 goes to 0, 2 goes to -1, -2 goes to 1, 0 goes to 3. Voila, mapping diagram. You've mapped every input to its output. That was super hard. Because I got lazy and didn't want to draw arrows anymore. As our next example below, is this a function? Yes or no? No, why not? Because one input has 2 outputs. This is not a function. The reason is 3 has 2 outputs. One input goes to 2 different outputs. Is our second relationship a function?
Yes.
Why?
Because it doesn't matter. Wait. Does it matter?
What's the definition of a function? Each input has exactly 1 output. Does each input have exactly 1 output?
Yes.
Yes, it does.
Yes.
Only goes to 1. Only goes to 1. Only goes to 1. Only goes to 1. I don't care where it goes, as long as it only goes to 1 number. They can all go to the same number if they want, but they can't. But as long as each input goes to 1 output, you're good. Yes. Function. And each input could go to the same output. In fact, each input will go to the same output if it's a horizontal line. That works. They all go to the same output. They all have the same Y. In particular, we're going to look at linear functions, something that you should have a ton of practice from your pre-algebra days and your algebra 9 days, and so forth. How do we graph a linear function or a line? Where's a good place to start?
Y-intercept.
Y-intercept. What's the y-intercept of 3x minus 5? Well, thinking y equals mx plus b here. How do you graph the line in slope-intercept form?
3 over 1.
The slope is 3 or 3 over 1. So we'll go up 3 and over 1, get a second point. And if you're intrepid, you could go up 3 and over 1, get a third point. And voila, graph of a line. Is that function a function or is that not a function? Definitely a function. There's no way to draw a vertical line to hit that line more than once. Please graph the second one on your own. -1, up 2 over 1. There we go. That is a review. I don't want to spend too much time on it. Tell whether a function is linear. What does linear mean?
Makes a line.
Makes a line. How are you going to tell if a function makes a line? What about the equation of a function tells you it's got to be a line and not anything else, not anything curvy, not anything else crazy? You're right. Linear functions, what's the general form of a linear function, of a line? What's your favorite formula everyone remembers?
Y equals mx plus b.
Y equals mx plus b. Everyone loves that equation. Notice it didn't have x squared. Notice it didn't have x to the third. It didn't have anything else. Mx plus b. If you can write it in that form, then you can get a linear function. So, is the first one linear?
No.
No, this is actually cubic. It's got a third power. Is the second one linear? Yeah, absolutely. Okay. Once you've done that, quickly evaluate what happens to those functions when x is equal to -3 on your own, please. It's 59. And we said that's not linear. Not linear. G of x when x is -3. So g of -3 should be 12 minus 8 times -3. 8 times -3 is 12 minus -24. Minus a negative plus a positive, and 12 plus 24 is exactly what most of you got. 36. Okay? So g of -3 is 36. We're going to look at some review, some statistics that goes along with these functions and plotting. In particular, look at something called correlation. Or how is the data related to each other? How is the data related to each other? If we're increasing, if the data seems to be trending up or increasing from left to right, like our first one is, this has very positive correlation. Correlation, or it's trending up. Since we're describing correlation specifically, if your line that you would draw has positive slope, then you have positive correlation. If the line you could draw through those has a negative slope, then we have negative correlation. Has negative correlation. If it's very clearly trending, like if it's very clearly fits a line, then the correlation will become very close to, if it's positive, then very close to +1. In fact, it's very close to +1. Because we can practically draw a line through every one of those points. If it's negative, then you can practically draw a straight line through all of these points going down. Or this would be close to -1. That does not mean the slope is close to 1 or the slope is close to +1. That means it's going up and the lines are and the points are very close together as though they're almost a straight line. Versus the ones that are below. What is this correlation coefficient? What is the, how are they, how can we describe the correlation itself? In part A, the data seems like it's trending down, but it's kind of spread out. right? It doesn't really fit a line so much, but it is trending downward. If it looks like it's trending down, but it's not really fitting a line, then that means it's not really close to -1, but it's trending down, so it's got to be something that's negative. In particular, we'll say probably not a bad option would be, say, trending like -0.5 be a correlation. The best fit here would probably be a correlation coefficient of down, but not really much of a line. Okay. In B, what's going on with the trend in B? There doesn't seem to be any sort of trend. If there's no sort of trend, what's the correlation going to be? 0. This doesn't really fit each other. Correlation, there's not really much of a trend. We'll say that it's not correlated. There's 0. And what do you think C should be? Like 1. It's definitely trending up, and it's very close to a line. It's very grouped together. 1.